Okay, so this is our last unit, the last homework in Unit 2. This will put the end of Unit 2 for us. Solving proportions. First off, what is a proportion? A proportion just means a proportion is two equal fractions, like that. Two equal fractions. So that's what a proportion is, two equal fractions. So how do we solve a proportion? That's what this whole homework is about, is how do you solve two equal fractions called a proportion? How do you solve that? Well, I think we need a little more room actually to do it well. So let me grab it and bring it on down here where we have a little bit of room. Here we go. Okay, so there we go. Okay, so question number one, let's do it. So anybody know already, how do you solve two equal fractions like that? Anybody seen this kind of thing before? Where you do those two, and then you do the other two. Diagonal, diagonal, you cross multiply. Two equal fractions, cross multiply. Diagonal, diagonal, cross multiply. Okay, so what do we have then? We have 2 2/5 times 50 equals 6 times x. It doesn't matter which one you put on the left or the right. You could put the 6x over here and the 2 2/5 times 50 over there. It's fine. It doesn't matter. Either way, it's all good. Just put one of them on the left, one of them on the right. Diagonal, diagonal, cross multiply. Okay, so now we're trying to solve for x. What do we do from here to solve for x? How do we specifically, what do we do with that mixed number right there?
We could turn it into an improper fraction, right?
Exactly. Good job. Does everybody remember that from the last homework? So let me write that again real quick. Mixed number, when you multiply or divide, you must change to improper, right? You must change to improper. We have to. So let's do it. So we multiply and we add, don't we? So 2 times 5 is 10, add, 2 times 5 is 10, add 2 is 12 over 50. No, not over 50. Can't be changed in the denominator, over 5. Times 50 equals 6 times x. Good so far? So we must change to improper. So next, how do we multiply 12 over 5 times 50? What do we do when a fraction is interacting with a whole number?
You put 50 over 1.
Yeah, right. Put this over 1, right? Just to make it look like a fraction. We haven't really changed its value, have we? 50 over 1, 50 divided by 1 is still just 50, but now it looks like a fraction, so we can do what we need to do. And what do we need to do? Now that we've made it look like a fraction, how exactly do we carry it out?
You could cross cancel the 5 and the 50, and you'd be left with the bottom and then 10 on the top.
Yeah, that's the easiest way, isn't it? right? Does everybody see that? That's exactly right. The easy thing to do would be to go 5 into 50 10 times. Really, I just divided both of those by 5, didn't I? Right? I cross canceled, dividing both of those by 5. Right? And then once we're done with that, we just multiply straight, don't we? So 12 times 10, right? 12, because that's all that's left on the left side of the equal sign. 12 times 10, 120. Everybody good there? We just multiply the 12 times the 10. There's nothing else left other than the 1, and the 1 doesn't do anything. So that's nice. We get 120 equals 6x. And then what do we do to finish solving for the x there?
You divide it by the 6.
There it is. Divide it by the 6. And that is 20. So our answer is 20. We got it. Does that make sense? Questions on that one? You good with all those steps? Okay, if I can, I want to answer. I want to leave no stone unturned. You know, you guys are becoming professional math and many other subjects teachers, and so I want to give you background information. Like for example, I don't want to just tell you rules without reasons. I think math is really boring if we don't have reasons. Like up here, I said we must change to improper. Why? Why? Let's answer that real quick. I think it's important that you know the reasons for things, because you're going to become a one who teaches others, so you want to know the deeper reasons why. So remember that when we add, subtract mixed numbers, right? When we add, subtract mixed numbers, we leave them mixed, don't we? We don't change them, we just leave them mixed. For example, if you have like 2 1/4 plus 3 1/4, we don't change them, we just leave them. We just go 2 plus 3 is 5, 1/4 1/4 is 2/4, and then we just make that 5 1/2, and we're done, right? We just leave them mixed. But when we're multiplying and dividing, we don't leave them mixed, do we? Why not? Let me come over here. So when you're multiplying or dividing mixed numbers, you must, it's a funny looking must there, you must change to improper, right? We talked about that last time, but I didn't have time to answer why. I think if I don't spend too much time, have a little bit of moment to say why. Why do we have to change? Why can't we just do it the way we did adding and subtracting with mix and just leave them mixed? Well, let's prove. So by answering the why, what I mean is I'm going to prove it's just not true. Let's take let's take 2 1/4. Let's go do the same problem. Let's take 2 1/4 times 3 1/4. Okay, over here we added 2 1/4 and 3 1/4. Now let's multiply 2 1/4 and 3 1/4. Well, how if we tried to leave them? Let's do it let's do it right first. How do you do it correctly? You have to multiply the bottom, add the top. 2 times 4 is 8. Add 1 is 9/4, and 3 times 4 is 12. Add 1, 13/4. 9 times 13. Then you just go straight and straight. 90 to 117 over 16, and then you got to divide on your calculator. I'm going to divide on my calculator right now. What is it? It goes in 7 times, and then 7 times 16 is 112, 5. So the answer would be 7 5/16, right? So that's the real answer. Okay. What if we try to multiply and leave, well, I'm right here, leave them as mixed? What if I tried to multiply and I left it as mixed? How would it work? 2 1/4 times 3 1/4. Instead of changing, what if we just left them mixed? How would you multiply those? How would you do it? You'd go 2 times 3 is 6. A fourth times a fourth is 1/16, right? Just multiply 1 times 1 and 4 times 4. 6 and a 16th, that's the wrong answer, isn't it? The real answer should be right there. 7 and 5/16. See how you get the wrong answer if you try to multiply them and leave them mixed? Do you see that? I just wanted to prove to you why we always say you have to change them to improper. It's because if you multiply them, trying to leave them mixed, you can throw out. Now, why? I still haven't totally answered the why. That's probably where I'm going to use too much time. It's because of what it is. What is 2 1/4? It's really 2 plus a fourth. That's what 2 1/4 really means, doesn't it? It's 2 plus a fourth. If I said, last night I ate 2 1/4 candy bars, that wouldn't be good for me. But if I ate 2 1/4 candy bars, that would be 2 plus a fourth. We all know what that means in the real world, right? To have 2 1/4 candy bars, it's 2 plus a fourth. And then if I said, no, I ate 3 1/4 sandwiches, then that's 3 plus a fourth. We know that's what that means. Okay, so that's what you're really multiplying. And how do you really multiply that? Remember from algebra, you would need to FOIL, wouldn't you? You would need to go 2 times 3 plus 2 times a fourth plus 3 times a fourth plus a fourth times a fourth. That's how you would really multiply. This is really required if we leave them mixed. And that would actually work. If you worked all this out, you could get the right answer, but that would be painful, wouldn't it? That's the reason why we change them, because we don't want to do that. That would actually be, this is crazy wrong right here. This is just crazy wrong. But this would be correct, but painful, right? This is true. That's how you would have to actually multiply mixed numbers if you wanted to leave them mixed. You'd have to FOIL, because that's what a mixed number means. It means two things added. 2 1/4 means 2 plus a fourth. 3 1/4 means 3 plus a fourth. You'd have to FOIL, and that would be a big pain. We don't want to do that. That's why we change to improper, because it's so much easier. Questions on that?